Hey! Welcome to 3D Printing 101, and this is for Matsuricon's 2020 online convention. So, let's get going. Hi everybody, my name is Megan Derwich, and I'm going to tell you a little bit about myself so you can understand why I'm qualified to talk about this. I've been cosplaying for about 10 years now, kind of on and off, and I am currently a polymers engineer at the Boeing Company. I'm the head of the thermoplastic simulation division. I worked in the automotive plastics, specializing in decorative for about 5 years. I went to school at Western Michigan University, got a bachelor's in industrial manufacturing engineering, and I'm currently going to Lehigh University for my master's in polymers engineering. And if you guys don't know what polymers are, it is just a very fancy word for plastic. um, so I currently have a few printers just kind of on hand. I have two Zortrax printers, one Creality Ender Series, and two Beam SDL printers. And I will go in what an SDL printer is compared to an SLA printer, but they're very similar. I also have access to this beautiful 3D printer that is down right in the corner, called the LSAM. The LSAM is a 3D printer that actually goes horizontal and takes up about a warehouse. It is gigantic. You can make full airplane wings in it. So it is a very cool printer to work with. So I'm just going to give you a little overview. So 3D printing covers a number of materials and processes and technologies. You can 3D print with a whole bunch of different kinds of material as well. 3D printing is a process of making physical objects from digital models and constructing them. There's a number of limitations in traditional manufacturing, which is why 3D printing really became a really popular thing. Mainly because specific designs were required for traditional manufacturing, and human labor hours were kind of a really big issue. The nice part about 3D printing is actually you can just plug it in and go. You don't have to sit around and watch it. So that is probably one of the biggest benefits of 3D printing. So what is 3D printing and what's the technology? Well, most three-dimensional models are used to create and created using a CAD system. So some of the popular CAD systems that are out there are Fusion 360, ZBrush, Maya, Inventor, CATIA, ProE, NX, SolidWorks, Blender, and some are actually able to use 3D scans and you're able to edit them. I do know that Fusion 360 is free, and so is Blender. And ZBrush, Maya, Inventor. Oh, sorry, Inventor is also free. ZBrush, Maya, CATIA, ProE, NX, SolidWorks generally cost a user fee. If you do get ZBrush, there is a membership, so you can you get like a renewing license. Whew, that was difficult. Models are created and put into a different program called a slicer, and it is literally sliced into different layers, and it takes the coordinates from the 3D geometry that you made in your CAD system, and it takes those coordinates and lays them out in respect to the actual part itself. When it's converted, it makes it into a file that your 3D printer can actually read. Your 3D printer cannot read files directly from your CAD system. It has to go through a slicing program first. Once your file has gone through the slicing program and put into the 3D printer, you can start printing. Yay! A material comes from the 3D printer and is then layered according to the coordinates that were given in the slicing program. So, in almost all 3D printing methods, it requires layering. And it builds layers on top of layers. Once that's all done and your part is complete, your part can be removed from the build plate and cleaned up and finished. So right down here is a picture of one of the models that I'm currently making with ZBrush. So what are the different types? So one of the biggest questions is you have to choose what kind of 3D printer that you want. And when you're working with 3D printers, you kind of also need to know, gauge what you want to be printing. So there's a bunch of different kinds, and I'm going to go over some of the really popular ones, but we're mainly going to be going over FFF and extrusion. But I will kind of give you an overlay of the other ones. So the first one, and it was probably the one that started 3D printing off in the first place, and it's called Stereolithography, or SLA. They all have very fancy names, but they all have acronyms. So you will see SLAs on the market that are not actually SLAs. They're SDLs, or yeah, SDLs. But SLA has been kind of the term that works with the photopolymer. And so it's kind of just become industry standard to talk about anything that comes out of a vat of like liquid resin to actually be an SLA printer. So let me kind of get into it a little bit. So SLA is a laser-based product that works with photopolymer resins. And what a photopolymer resin is, it means that it's a resin that is a reactant to light, specifically UV light. This material reacts with the laser and cures to a form in a very precise way to produce very accurate parts. The photopolymer resin is held in the vat with a movable platform. And so you can see right in this location, this is the movable platform that's moving down. This is your part being made, and this is the laser that is moving around to create those layers. The laser beam is directed in an XY axis across the surface of the resin according to the 3D data that is provided. So that is the 3D data from the slicer that I mentioned before. The resin is allowed to cure, or also known as harden, and it moves to the next layer. And then it just continues this process until it's done. And you take the part off and you let it cure in a UV chamber, or literally I've taken them outside and cured them outside in the sun. There are a few downsides, but there's also a bunch of benefits about using SLAs. So some of the benefits that come with SLA printers are they are extremely accurate. They are extremely accurate. You can make extremely tiny parts, and you get a really good surface finish. And you don't get as much warpage as you would see on a normal extrusion printer. So why would you want an SLA printer? One of the major benefits is that with an SLA printer, you're actually able to make miniature things. So when I say miniatures, like D&D campaign, like miniatures, and parts for your Gundam and stuff like that. So they're mainly made for small parts. So that's kind of one of the drawbacks. So some of the disadvantages is that it is a messy process. If you have to take your part out of the resin, it's always kind of sticky. It's just, no matter how you do it, the resin just kind of gets everywhere. And I'm not trying to deter you, but if you are looking for a process that won't get everywhere, I don't suggest this one. You still unfortunately need supports. And I'll kind of go over what a support is later on, and it does require them to be manually removed. The only kind of downside about this is you only get one resin. You get what is in the vat. So that means you get one plastic, and so that means that you can't have a water soluble support that just kind of melts off. You have to manually go in with clippers. I have some right here. Yeah, you have to manually go in with clippers and kind of clip them all apart. Um, the other downside is the photopolymer resin isn't actually that stable. I know, I know, I know. It's devastating. But you can make really pretty clear parts and you can make really pretty clear gems. One of the major issues is that over time, your polymer will continue to degrade. And because it's sensitive to UV, if you take it outside, you're going to start seeing discoloration and it's going to become very brittle. So there are ways that you can combat that, and that's putting UV protected clear coats on top of the things that you want to stay clear. It will just degrade the plastic a little bit less, so you'll have your part look like wonderful gems for a little bit longer than you would if you didn't coat it. It has a really hard time making large parts. And the only reason why I say that is because most of the bed like sizes that you print on, like the print sizes, are actually pretty small. So unfortunately, you have to break apart all of your stuff if you really want to make a large print with an SLA printer. So the next type is called a DLP, or a digital light processing printer. It is almost exactly the same thing as an SLA printer, but they kind of works in the opposite direction. So instead of your part forming inside this vat of polymer, it lifts out of the vat. And one of the reasons why I like this process just a little bit more is because when you do take your part off of the build plate that's right here, um, it's not dripping of your resin. It generally has dripped all of your resin off of it. So that's probably one of my favorite things about this. Kind of one of the major differences between an SLA printer and a DLP printer is how the light is projected. So it uses a more conventional light source with a crystal liquid panel, or a deformed mirror device, which applies to a light to the entire surface of the vat of the photopolymer resin. So right down here is generally a clear sheet of plastic, which is called, it's a tensioned film, and it's called an FEP film, or FEP is also known as Teflon. So if you guys think about pans in specific, like cooking pans, the Teflon finishes on cooking pans is an FEP layer, and it helps things not to stick. So, what are some of the advantages? So, once again, similar to SLA, it's extremely accurate. You can create very tiny parts. The surface finish is really good. It takes less time to kind of deal with it. You're dealing with less wasted resin than you are with the SLA printer. And you don't, unless you're like me, when you try to like take it off the top and then you drop it immediately into the little vat, you don't end up making quite as much of a mess. Just don't be like me. It also has a low running cost, and when I say sort of on here, I mean sort of. So one of the major things that you need to be aware of with both SLA and DLP printing is that they require the room to be really hot. So unless you have your printer in an encased and enclosed and heated enclosure, you have to heat up the whole room to be hot enough for the resin to really work well and to get the quality that you need. So you do run up the cost of your heating bill and electricity bill from your heating, and plus you're running the printer. So that's why I say you sort of have a better running cost. But during the summer, it's actually probably one of the most cost efficient printers to run. So one of the other disadvantages, once again, messy resin with the SLA. You still need to put supports. Unfortunately, the resin is the same as the SLA resin and isn't very UV stable. And it's hard, once again, to make large parts. What's also kind of nice is that you don't have like a large vat of resin. You only have a small layer that's on top of it. The only downside is that you can also run out of resin pretty quickly if you're not paying attention. These are kind of long prints, so if you're not paying attention and kind of constantly stopping it to make sure, um, that is something that you just need to keep track of. Okay, so this one is by far the most popular and most recognized 3D printing process. It is used in industry, it is used in hobbies, it is used in cooking, it is used everywhere. So, what is it? So, extrusion, FDM, and FFF 3D printing. They all go by those names. And what it is it is the process of working with a melted plastic filament that is deposited via heated extrusion, which is like right here, one layer at a time on a build platform that moves. Either the extruder head will move or the plate itself will move. Most of the time, it's the extruder head that moves. Each layer is hardened as it's deposited and bonds to the previous layer. So what are some of the advantages of getting this compared to the SLAs that I have mentioned before? Well, yeah, you can use multiple resins in this. Why is this so cool and why am I so excited? Multiple resins means that you can support your material with water soluble supports. That means you just dunk it into water and it just dissolves your supports, so you don't have to go through and manually remove everything with these lovely little clippers. So, that is why dual extruders are so freaking cool. Also, with having multiple extrusion heads, you're able to do different colors and you're able to kind of make things just a little bit different. And they're currently making extruder heads that have like 4 or 5 different extruders that specifically work with the primary colors, and those primary colors can mix and match and they can do in color prints, so they don't require any painting afterwards. So that's one really cool thing that's been happening. It uses probably the widest variety of materials. They are very common. You can get them from Amazon. You can get them from um, the printer. A lot of times, 3D printers have their own proprietary blends. You can get them at Micro Center. It's kind of everywhere and it's kind of popping up in a bunch of different places. So the materials are pretty easy to find. Um, and it creates much larger prints, mainly because the beds are so much larger. It's a lot easier to keep these heated, and so you can just make much larger parts. So, what are some of the disadvantages? And I'm going to try really hard not to make this sound like a terrible process, but there are some major drawbacks when you have to deal with extrusion 3D printing. So, one, the material is very heat sensitive, specifically because the type of material that it is very sensitive to heat. It is very sensitive to the outside surrounding temperature, and it's very sensitive to heat fluxes. So, say it's a cold winter day and you're printing in an area that has a draft. So it's nice and warm, and then all of a sudden there's a draft of really cold air. Why does that matter? It will cause layers to separate. It will cause the part to completely separate from the bed. There's just a lot of issues when it comes to temperature when you're dealing with these. Unfortunately, we're still in the day and age that you need supports. Whether they're water soluble supports or whether they are a different material supports, you still need supports for your part. Generally, these are not watertight. There's always just kind of like little tiny gaps everywhere. You can end up making these watertight. But that just takes post-processing and secondary operations. So a lot of the material actually really doesn't like acetone. It doesn't like nail polish remover. It doesn't like a high paint thinners. So you have to be very, very careful with how you're painting these parts. You can't clean them with acetone. You can, but you run the risk of damaging your part, as well as damaging the thickness, or sorry, the strength in between each one of the bonds of the layers. So you don't want to destroy the strength that you have from layer to layer. So that kind of brings into the next point. If you do end up destroying those bonds that happen in between those two layers, what happens is they become weaker and they just start separating from each other, whether it be from heat sensitivity or you're applying a force and it's just not strong enough to hold it. I'm sure anyone who has dealt with a 3D print has dealt with it breaking. Unfortunately, it's just kind of a hazard of the trade. But it is probably one of the more common issues with extrusion than it is with the SLA and the other types of 3D printing. So finally, as I mentioned, with the heat sensitivity comes along warping issues. And a lot of times what you'll see is, even though you have these specific coordinates that happen with your print, you'll see that sometimes it kind of lifts up off the printing bed and causes it to warp. Sometimes you'll see that it'll kind of warp inwards. And what is warp is just, it shrinks in different ways and it differentially shrinks. So, it just, unfortunately, that's what it's called. It's called warp. So there is quite a bit of warping issues when it comes to extrusion printing. But please don't get me wrong, it is the most common method. Everybody kind of deals with these issues. And the benefits outweigh the negatives. You just have to design for them. Okay, so there are a few other parts or types of processes that 3D printing have. Laser sintering, laser melting. Inkjet has binding jetting and material jetting. Selective deposit lamination, so SDL. And actually, I messed up on my slide, my introduction slide. I have an SLA printer. And then electron beam melting, so EBM. They actually have started coming out with this new method that takes ultrasonic creation and SLA printers, and they actually combine them, and it is the only process that doesn't require layers, and it doesn't depend on layer action. It just kind of forms in a vat of goo. It's a really, really cool technology, but it costs about $8 million to get like a tiny little piece that's like that big. Okay, so materials. 3D printing is such a cool new technology. Actually, it's been around since like the 80s, but still. That there are so many materials now and so many companies that are coming out with some really cool materials that you can use in your 3D printing. So plastic, that is the number one thing that you will probably be using in your 3D printing experience. The reason why plastic is so popular: one, it's very common. Two, it's very easy to make a filament. Very, very easy. It also has a wide range of engineering grade all the way up to commodity grades. So that means ABS, PET, PETG. There are biodegradable polymers as well, such as PLA. And there also have some other ones, such as the water-soluble material that I mentioned before. They're generally amorphous materials, and this is just kind of going into the chemistry a little bit. So if you want to learn more, make sure that you message me, or I will have these slides available so you guys can kind of research on your own. But they're generally amorphous materials due to the fact that semicrystalline shrinks so much, it kind of just always shrinks a lot. And the melting point of polymers, it's much lower than metals and much lower than ceramics. So it's kind of the most optimal material to use. What is really neat is right now TPUs, TPOs, and TPEs, which are all known as flexible materials, are kind of just becoming available and just becoming very widely accepted as a polymer to be used in 3D printing. I will say, make sure if you're looking at a printer and you want to be printing these flexible materials, make sure that your printer can handle them. Not all printers can, and a lot of times it just ends up jamming up the gears in your 3D printer. So make sure that you're checking the details that are on your 3D printing or printer. So the next one is metal. You can actually print with metal. The most commons are aluminum, cobalt, stainless steel, silver, and gold. They're generally in polymer form, or sorry, powder form, but it requires sintering, melting, or the EBM process. They're a little bit harder, but there's a lot of companies that are out there right now that offer this as a service. And you just go into their website, you upload your design, and either they will quote it right away or they will call you with more information. So if you're really into making, say you're really into making silver jewelry, you can go to these companies and you can get them done. It's definitely more expensive, but it's really, really worth it, and you get some really good results and very unique results. Um, Also, what's very neat is that they've been taking a lot of metallic additives and they've been mixing it into polymers. So why does this matter? It actually means that you can have a magnetic part if you really wanted to. There's some really cool work. It means that you can print it pretty regularly with your extrusion printer or your FFF or FDM printer. And it's allowing metallics to kind of become more available. And because it is metallic, it does have that extra strength that polymers just don't have. So it is a really cool material. Um, So ceramics is still being worked on. They're actually working on it specifically because they can print it, but it still needs to go into a kiln. So it's still in development. You can actually print with 3D print or with paper. It's kind of a really neat process. You can make decorative laminates that are like wallpaper and it's 3D. So if you ever touch like a 3D wallpaper, you'll understand it. And it's actually used day to day on your standard printing process is actually technically considered an SDL process. So, fun fact. Biomaterials. So, a lot of work right now has been in biomaterials because 3D printing is such a really cool technology that you can actually start building organs. So cool. It allows to print in a structure and in a material that is more commonly accepted by the body, and your body eventually eats away at it and replaces it with its own cells. But it has completely revolutionized how medical practices are happening. And then finally, and this one is just pretty cool, is food. You can 3D print chocolate. You can work with sugar, pancake, pasta, and recently meats. But they look really weird. Over here is a picture of a 3D printed meat that consists of fat, blood, and muscle. I mean, it doesn't look like anything that you'd want to, and it reminds me of Play-Doh, but honestly, it's a really cool technology that will help bring the cost of meats down. So it's really exciting. Okay, so design for 3D printing. This is a topic, guys. This is a topic, and when you're designing for 3D printing, you have to take in a whole bunch of different considerations, your orientation on how you're printing it, the size of the bed, where it's printing. You have to take into consideration supports and all of this. So I'm going to go over some of the common mistakes that happen with 3D printing and how you can avoid them and how you can make them look better. So overhangs and holes. Overhangs present a challenge in 3D printing if you do not have support material. When you're printing an overhang that's generally steeper than 45 degrees, the filament is kind of open in the air and it causes itself to droop. Sometimes it can kind of fall off. So normally what you should do is you don't design overhangs that are steeper than 45 degrees unless you plan on supporting them underneath it. And the other thing, unless you have a dual extruder, you have to remember that you need to be able to get these supports out. If you can't reach it and if you can't get into it to get those supports out, those supports are permanently there until they just kind of fall out. So make sure that you're designing with the intent of getting the supports out as well. The same thing kind of happens with holes. You can kind of see, first of all, if we look at this picture of overhang, you can kind of see how without the supporting, your edges start looking kind of rough, and then eventually they kind of flip up, and you start seeing kind of strings of the polymer kind of fall off. You can see the little dark brown spots, which are burned plastic. So this is what would happen if your part is not supported. Holes are the same way. If your hole is not supported, you can actually kind of think of it as like your walls are legitimately going on 45 degrees, but they're just in a circular matter. So you just kind of need to have this in mind while you're designing. Support your print. I cannot stress this enough. I have had so many failed prints because I didn't support it in the right spot, or it fell off the build plate, or just, oh my goodness. There has just been so many mishaps because I just didn't want to support. Because it takes time. It takes time, it takes material. So if you do not support things correctly, your part will fail. And you'll get a mess like this. So not only do you waste material, but you also wasted all that time to get up to this point for it to fail. It does take more material and it does take more time, but it definitely takes less than a failed print. So just kind of keep that in mind, especially if you're on a deadline and you're really trying to crunch this out. Make sure to support and take the time to support. Not all slicers auto-generate supports. So this is kind of a new feature that kind of came about 2 or 3 years ago. And auto-generating supports, your slicer actually goes through your model and identifies anything that's above a certain degree angle. For my printers, it's set for 20 degrees. And normally it just kind of goes through and manually will add them and add the type that needs to be in that location. But sometimes you have to manually support it. Certain softwares act kind of differently. Sometimes you can kind of start getting a feel of your printer and you can say, well, I, I know that I had a lot of issues and a lot of warpage problems before on anything that's more than 15 degrees. And that was kind of, you start learning your printer and you start kind of understanding where you need to manually add supports if it's not auto generated and put in for you. It does take time. It is a little bit frustrating, but it is a good practice to do, is to kind of look through your model and make sure that it is properly supported. So another added bonus that supports give is that it allows your part to have a little bit more surface area that is connected to the printing bed. Why does that matter? Plain and simple, while you're building up parts, as you can kind of see right here, this is almost suspended in mid-air until it's connected onto your actual part. If this isn't supported correctly, it will just fall off. And it doesn't have anything to build off of. And so sometimes what will happen is your extruder will literally knock parts off. It's just kind of going so fast and putting so much force by trying to put these polymers on, it will just knock the parts off. So sometimes you can use supports to actually anchor things onto your bed of your platform. It's a good method that's kind of a hidden secret that not a lot of people think about, but it makes sense if you think about it. Okay, continuing on. Wall thickness. It's very, very easy to make parts too thin for 3D printing. And you have to remember that there is a small nozzle going around and laying these down. Well, if you only have 2-layer thicknesses of your wall isn't going to be strong enough. So you need to kind of think about it. You need to think about the strength of your part that you need. You also need to think about, how easy is it going to be to break. I've had it where I've printed way too thin, I've dropped my part, and I broke it, like immediately snapped it in half. Although it saved me polymer because I wasn't, or like material because I wasn't making it quite as thick, I wasted a ton of time and I broke it. So, I mean, I ended up wasting it anyways. So, make sure to listen to your 3D printing software. Sometimes it'll tell you when things are too thin, but definitely kind of think about the kind of forces that are going to be put onto it. Like if this is going to be like an up and down part, make sure that you're printing it in the right way. Okay. So because 3D printing is a really cool process, you don't always need to make things in you don't need to make it solid. A lot of times you can make screws, you can make threads, you can kind of take into consideration, like if you want to screw something into your part. But you need to take into consideration something called hoop stress. And I know this is technical and I really don't want to get into this and like bog you down with information, but it's a normal stress parallel to the axis of the cylindrical symmetry. So what that means is it is just imagine a hole and something is in the hole that is pushing against it and it wants to break apart that hole. So this is a very important concept because if you're putting a PVC pipe into a hole of a part, so say you're making a staff, you want to make sure that you leave enough room that PVC pipe doesn't actually end up breaking that hole. So you got to take that into consideration. So another thing that is kind of handy with larger parts is you need to recognize how big your printing bed is. By understanding your printing bed, sometimes you just can't print that giant breastplate all by yourself, or oh my goodness. Sometimes you can't print that giant breastplate all in one go. A lot of times what you need to do is you need to cut apart your parts and kind of think about where you're going to be making this into pieces. So joints tend to be the weakest area. So you generally design them into your part or into the lower load bearing areas. And so you don't want to put a divide. So say you cut the part in half and it's right in a joint. You generally don't want to do that. You want to kind of put it in an area that won't have that kind of stress and like load bearing onto it. A lot of times recently you can I've seen a lot of this. You can make dovetails, which is a really cool, almost like jigsaw-like looking slots. So you kind of can design slots in specifically for your parts to be connected. Why does this help? Well, if you design it in a way that allows for connecting rods or things to be lined up, one, your part is lined up. Awesome. And then two, it also provides a much stronger joint. So where the two are bonded, instead of having a flat face to face, you have a mechanical locking device that locks that part in so it's not shifting around or breaking. There's just like another device that's keeping your 3D print from separating from each other. Okay. Similar to EVA foam props, you can use wood, metal, or PVC pipes inside of your parts to kind of keep them all aligned. I have 2 keyblades, and all of those keyblades either have a PVC or a metal rod or a wood rod in the middle of them, and that's to kind of keep them stable to prevent them from separating at those layers like I mentioned before. And it also just kind of adds a little bit more robustness to your 3D print, and you feel a lot more confident when you're walking around in cosplay. Okay, choose the right material for the right job. So, as well as choose the correct printing method for the right job. So if you're building a gigantic prop that is absolutely like it's 6 feet tall, it's like a giant sword, my suggestion is not to use SLA printing. Because that's going to be 9 million parts that you all have to glue together, and so you're depending on the strength of the glue more than you're depending on the strength of the print. So that is definitely choose the right material for the right job. Some other like suggestions with the right materials. So if you're using generally a really soft material, for the outside layer of your part, you may want to use for some of the support features that you're making on the inside of your part. If you're printing them separately, you may want to print them in a different material that's just a little bit stronger and a little bit tougher. So it provides that strength on the interior, but the exterior, because it's ever so slightly softer, you're actually able to take an impact. So say you accidentally drop your prop and it hits the granite floor and you're like, no, slow motion. With the softer material, it's actually able to hit the floor and, maybe it doesn't crack, or maybe it just ever so slightly dents. That's way better than completely snapping your part in half. So just kind of take into consideration the materials that you're using when you're choosing to 3D print. So this one is a time related bullet point. So remember that smaller details are harder to print, sand, and finish. You kind of want to slightly over exaggerate fine details in your 3D print, and the only reason why I'm saying is that you want to over exaggerate these in your design method is because when you do paint it or you do your finishing, you tend to smooth those surfaces, or you make that definition of your fine detail less defined, and you kind of lose that effect. So if you want this to be a grade A amazing prop, make it just so your details are raised a little bit higher so we can see them. Also, it just takes so much time to do finer details. So make sure that when you're budgeting your time, you kind of take into consideration that like it takes a lot longer to sand these. It takes a lot longer to finish them. And also you need to finish those hard to reach areas. So kind of take that into consideration as well. So think of the end product. When designing, think of where the parts need to go or need to go into the part. And think about the stresses and the loads and things like that that your 3D print will be handling. So you just kind of have to think of the overall picture of what's going to be happening with this 3D printing. Um, so down here, I have a lovely example of how to avoid supporting. So you can see that the supports are kind of right here on the side. If you cut it in half, you actually don't have to deal with that, and you don't have to deal with as many supports, and it doesn't take as long to print. So that is one of my big suggestions, is kind of eliminate supports where you can by using those cutting, and then make sure when you're cutting those pieces that it's a structural area that you can actually like make sure that it's strong and you're not just depending on that bond. Finish your prints. um, so minimize the amount of finishing work necessary for your 3D prints by starting at the very beginning of the printing process. So what do I mean by that? Layer heights actually contribute a lot to how the finished product looks. So thicker layers tend to be more visible and don't blend into each other as well. Um, and thinner layers take a lot more time and a lot more detail, and you run a lot of more risk of, having a failed part, but you get a much better looking part. And it takes less sanding, less bondoing, less filling, but it definitely takes a lot more time. So printing speed is another important setting. How fast your print travels when extruding the filament. The speed depends on your objects. A lot of times, if it's too fast, you can lose quality, and it kind of gets these like weird lumps in it. And if it's moving too slow, you also get uneven layers, and you'll start seeing it where it kind of looks like a little bit off in certain areas. Like sometimes it'll be like a slightly different color, and if it's printing like that, like you can really mess up your print. So make sure that you've optimized that your print's speeds. A lot of times with more complex objects and things like that, it actually benefits you to have a slower print. But it's also, once again, it is knowing your printer. Get to know your printer. They are living, breathing creatures, even though they're not breathing. But they have finicky settings and areas that they may or may not like. So just make sure that you get to know your printer and kind of the do's and don'ts of your printer, and what works best. For my printers, working at fast speeds are just, it's not its jam. Does not like it. I always get failed prints and just ugly prints. So, you just kind of got to learn your printers. Cheap filaments don't always mean that they're good filaments. They Sometimes cheap filaments are amazing. Like you got a good resin. But a lot of times what happens is the cheaper the material, the more impurities it has. The more impurities it has, the material melt temperature might be different. The extruding might be different. It might cool different. It might have different strength. I've ordered material before that was incredibly cheap, and I was like, I got a deal. But every single print that I printed with it, it failed. Every single print. So what I'm saying is, if you want to buy polymers, kind of think about, if you're buying super cheap, then you know that you run the risk of kind of having a dud of a material. Also consider, if you don't want to paint, color of the filament. Think about the color of it when you print. You can kind of change materials. You can change the dual extruding to deal with the different colors. If you do have a dual extruder, if you don't, you can sometimes just change the filament while you're printing, and it helps that. But yeah, it also helps I like printing with strange colors, just because they're generally a lot cheaper if you buy them. And so you generally want to find a color of the filament that is very close to the color that you're going to either be painting it, or the color of the actual part. So in order to help with the read through into the paint, you generally want to keep it kind of the same tone, or you want to go with a black or a darker color. Unless the part needs to be white, then, preferably print with a white. Sand. I cannot stress this enough. sand your life away. This is probably the most frustrating part of 3D printing, and it is one of the simplest and easiest way to finish a part is to sand. Some materials really don't like to be sand, like PLA and some ABSs and like the harder materials, you'll have a much harder time sanding. It just kind of takes a lot more elbow grease, but you guys got it. You make a good quality part with sanding. So there's multiple grits that go on sandpaper. So if you don't know, you actually want to start with a lower number of grits. So, and then it goes up to the higher numbers. So, the lower number of grit have a larger sand particle that's actually on the sandpaper itself, and then the higher numbers is the actual like how many are in like a little corner of it. So I think the highest that I've ever seen in a sandpaper is about 4,000. um it requires to be wet sanded, but wet sanding helps reduce the friction, and it also gives you a really, really pretty surface. It's shiny and it looks really nice. So although it's an extra step and it is a lot of work, honestly, I would say like wet sand all your parts because they just look so nice and you can't even tell that it's a 3D print. One option that you can do is a vapor polish, and unfortunately, it's a little bit more process intensive, I guess is the best way to say. So a small amount of a solvent, generally like an acetone or something like that, is placed inside a container. The print is kind of put into the container and it's suspended over the solvent, so you can kind of see that there is it's on a little table. And what happens is you put the cover on and it starts heating up the solvent because the two are reacting with each other, and it's a cool chemical reaction, and it causes the top layer of um your print to melt. So if you have really large non-detailed parts, I honestly suggest this. It gets your sanding done and your finishing done very quickly. The issue is you need to watch it. It happens very quickly and it melts the top surface, so technically you are weakening your part, but it happens extremely quick. So you can kind of see in this picture over here. So this is the 3D printed part. This is what it looks like sanded, and this is what it looks like after vapor polishing. So here are the steps that I generally take when I'm finishing a part. So connect all of your your prints using some of these methods. Okay. Um, these are from the most common resins. Specific resins might need specific things. So make sure if you're using like a specialty resin that you know what will bond well with it or what will not. So, but for very common resins like PLA, ABS, PC ABS, super glue. Super glue is great. It's cheap. It's easy. Super glue is probably one of the best things to connect these parts. 2-part adhesive. So those 5-minute cure, the 1-minute cure epoxies that you mix, that's another great one. And then you can use pins to connect the plastic, and like you kind of coat them in epoxy and you just kind of like smush them all together inside like holes and stuff like that. That's another great way to connect your part. Find a way to mount your part. And the reason why I'm saying this is that it helps with painting and it helps with priming. And it just kind of takes a step out of like, flipping your part over and then painting one side and then flipping your part over again and then painting the other side. So just kind of find a way to mount your part. Prime the part. So you can use XTC 3D, which is just kind of an epoxy that goes over it. Make sure to get the mix ratios correct on that, because if you get them wrong, your part stays sticky and it's gross. Filler primer. You can get it at any Home Depot, Lowe's, anything like that. Show show the places that need extra sanding some extra love. So, you may want to go in there kind of ahead of time with a rougher, like way rougher sandpaper and kind of get those areas really, really well. Even if your whole part doesn't require that rougher sandpaper, you may want to get that one area like extra with some sandpaper. And then the end all be all of printing, Bondo. You can use Bondo to fill in seams. You can use Bondo to kind of deal with like uneven surfaces. You can kind of see sometimes you can fill in the layer gaps and stuff like that. Sometimes with 3D printing, it doesn't do rounded corners super well for some reason sometimes. And so you can use Bondo to kind of help round those corners out. Sand. Once again, I cannot stress sanding enough. Start with the lower grits and then go higher. Prime again. So this is kind of a polish. So you prime using just a standard paint primer and then you polish it after that. Then you want to apply an undercoat. So the undercoats are mainly used for a deeper, richer color when you actually paint. It blocks the neutral and flat colors of the primer. So sometimes colors can kind of bleed through into your paint. So you just want to make sure that you put kind of an undercoat so it kind of helps give you a nice, deep, rich color. Buff using a nail buffer. This one sounds weird. You can also use a Dremel buffer to do it as well. Sometimes if you're doing much larger parts, you can use an actual like buffer, but buff that part, make it shiny, make it look good. Then you generally put a top coat, and then you can either clear coat, floor wax, or seal. So these steps are mainly used for like very glossy, like if you're trying to get a metallic look or like that really nice, clean, glossy look onto your 3D print. If you're trying for that like rough and like rigid, you may want to, skip a section. So you don't need a buff at all if you don't want to. And if you like that matte look, you can just leave that primer grain and it leaves kind of a neat matte look, as well as you can use a matte finish paint and it'll give you kind of a rougher-esque surface that diffuses light better and it actually causes it to look matte. So but I do honestly suggest with paint and with 3D prints, top coats are great because they're UV resistant normally. So make sure to check your paint, make sure everything is UV resistant. Okay, so I get this a lot, and I really want to give you guys some printer recommendations that are currently on the market and are things that either I personally use or have used, or I have seen really good reviews and things like that for it. So if you want to get a professional series 3D printer, they're generally more expensive, they're much more accurate, they have a lot more features, and they can generally do a lot more materials. And the only reason why I say generally is like sometimes they literally specialize in like two. But make sure to kind of think what you want with your 3D printer. So if you want a dual extruder, make sure that you're looking for printers that have dual extruders. If you want to be able to print TPOs and TPUs and TPEs, those flexible filaments, make sure that you're getting a printer that will also be able to do that. So kind of make sure to look at the detail specs. Don't just go with, oh, this one's cheap, this one works. So just kind of think about what you want with your printers. So for the professional series, my recommendations are, drumroll please, Zortrax. I cannot stress it enough. Probably one of my favorite brands overall. It's so user friendly and it's such a great group to work with. Ultramaker, I have never had a problem with Ultramakers. They have been a phenomenal investment for my work, and I just absolutely love them. They do a very good job. They have different build platforms, just all around. A lot of professional prop makers have Ultramakers. Raise 3D. If you guys follow Riddle, she actually prints for Marvel Studios using her Raise 3D printers. And they are huge. And then if you're looking for an SLA printer, my suggestion is to go with the Form Labs brand. The only reason why I'm suggesting kind of Form Labs, even though it's the more expensive of the printers, they have a really solid process. Their software is really good. They don't have as many issues with breaking down. So all in all, I really, really like Form Labs for an SLA printer, and it's worth the money to invest. Okay, so the hobby series. The hobby series are generally less expensive. They have slightly lower accuracy. Sometimes they have less features, and sometimes they can only work with certain materials. But this is sometimes. Hobby printers have really come a long way in the past 2 years or so. But I really have 4 main hobby printers that I trust through and through. And that is the Crealities. Crealities are probably the new up and coming in the 3D printing world because they just have a really good setup. They are very easy to use. The bed is very it connects to a lot of polymers, and I don't know, I really like them. But they have the Ender series and the CR series, but that is Creality. Um, Lulzbot. Lulzbot is actually available at your local micro center. It is one of the few 3D printers that you can actually just go out and go to a physical store and buy. Um, I've heard that they're kind of expensive, but it's kind of neat that you can just kind of go out and buy a 3D printer that is pretty reliable and has some pretty good slicing software. Precious have been around forever, but they are very user friendly and a good plug and play 3D printer. MakerBots, what to say about MakerBots? They're actually used a lot in schools. A lot of people are taught on MakerBots. They're very easy to understand. They're great plug and plays. It's very hard to break them. They are robust. So if you do have like younger kids around, maybe consider a MakerBot because it allows them to have something that they can learn on. If you are a parent and you want to kind of teach your kids some cool 3D printing, Dremel just actually came out with their own personal 3D printer, and it is in a very robust case, and it's also meant to get kids into 3D printing. So there are my printer recommendations. And then finally, those medias. If you guys have any questions, if you are having printing problems, if you have issues of any kind of 3D printer, or you don't even know what 3D printer you want to go for, make sure to, to ask me. I will be more than happy to answer any of your plastics questions. Even if it's like, I don't even know what plastic to use for this. I got you. So hit me up and make sure you like, add, subscribe, and follow on all of those social medias. And thank you everybody for coming to Matsuricon's online con. And thank you for sitting through this incredibly long lecture on 3D printing. And thank you for your time. Have a good day. Bye.